know what is really normalization. Normalization is think about so whatever we are doing in the computer science or any like the research, we try to after we implement what design and proposing, testing everything, we need to evaluate, right? For the evaluation, there are a bunch of different ways. So sometimes, so we call such an evaluation as the goodness. How much good the result is, whether this result, this design is good or not. So then we need to measure. We cannot just say this is good, this is bad, this is excellent. We need to measure, like the 0 to 10. So it's a 10 out of 10. It's excellent. And 0 out of 10. So this is one of the way categorize and survey and decide. So in the database design, we use the similar way. It's called the goodness measure, whether this is good or not. When we determine whether this is a really good design or a bad design, we need to have the criteria, rule, or the guideline. So for that guideline, the first overall goodness measure, goodness criteria is what? Whether there exists redundant information or not. In case you have the redundant information, duplicate data, it's very hard to manage and it's very slow to search the data. So we try to think about the ER modeling or think about the database, the relational database conversion. Okay, we try to get away from the redundant information. So really, it's in general, the database developer, database administrator, they really hate any redundant information, duplicate data. So for example, this is just an example. Sometimes when you work, if you work for the database administrator, from time to time you need to upload, batch load from ASCII text file, CSV file, or just a text file you need to upload to the table. Okay? So that is looks like very simple using the program or the tool to upload the test file or data file to the table. But in relational database, it's not such easy. There are a lot of things you need to consider. Most serious and the most tired job is in case there is a duplicate data, especially for the primary key. So you cannot create a primary key. That's the huge problem in case there is a duplicate data. So for example, Oracle, we are not using the Oracle. For example, Oracle, there are a bunch of error number, which is error code. And also it's standardized. SQL, the ERR. So SQL ERR, so they are the standardized. So each and every the DBMS database software use the SQL error code. So it's very important to check the such error code. In case something problem, check the error code. In case something issue, what is error code? What is the error code number 1 in Oracle? Can you guess? It's the primary key violation. So when you have the duplicate data on your primary key, it will be the error code number 1. It's called ORA 00001, something like that. It's a 1. You can search the Google even. It's a primary key violation. So which means such a duplicate data, redundant information will be kind of a guideline to measure how much good your design is. So normalization process can be used for such a goodness measure. That's one thing. So that, for example, after you design your database, your manager will ask you, please check the normalization, third normalization, or the something normalization, whether your design is perfect, good or not. Then that is a guideline to judge how much your database design is good or not. Another approach, another example of using the normalization is, today we will see such an example. In case simple, relatively simple database design, you can use only normalization process to design. You don't have to follow the logical modeling, the physical modeling, whatever the process. Instead, you can just use normalization to design. So we will see such a, in case a relatively simple example, simple database, we can use the normalization. So we will see what is the normalization today, and the last class we talk about the informal way. Informal means informal. Non-mathematically, we discuss about that. Do you remember? You are so smart to remember all the guideline. First, how many meaning for each table? When you create a database, how many meanings? Two? One table, two meanings? Only one. In common sense, I'd like to create a student table only for student. I'd like to create a professor table only for professor. I don't want to mix up. Why? When you mix up professor plus student, it will be redundant and huge problem. So first guideline, one table, one meaning. That's obvious, but that's very important. Second, we will see the example. I didn't show the example of such anomaly. So for example, let's take a look at this. This is my database design for the employee, the company database. I know even this violate what? First guideline. How many meanings? Employee and project, right? So we have this. Let's suppose that this is the result of the database design for the company. So check with the first guideline. How many meaning? Employee and project. So it should be the redundant. Second guideline is no anomaly in case when insert, delete, update the data. For example, I'd like to update the data. So in this case, the employee number, project number will be the primary key. Then I'd like to update the project name. Okay? So project name is changed to from P1 to P2. What happened? How many projects do you have in your company? P1. How many P1 do you have? P1 is just one. However, if you update this database, for example, employee number, project number, E-name, P-name, and number of hours. For example, real data, 111 P1, the lead, and sample project. Number of hours. 112, P1, and James, and sample, and so on. If you update the sample to real, how many times you need to update all this information sample to the real? Okay? Even though you have the one sample project, you need to update them many times. Why? Because of the redundant information, which means your database design is not good. Okay? So second guideline is no update anomaly. And also another thing is, what if there's a sample project and all the other project, only one employee for the sample project. What if you delete this row? The employee 111 is retired. Then where is the sample project? Sample project is removed automatically. Even though there is no employee who works for the sample, but the project is still exists, right? But because of this problem, because employee and the project are together in one table, so it is the problem. So it's called the delete anomaly. So update and the delete anomaly. I have the new, the employee 111, but it's not assigned to the specific project. But you cannot. You need to decide the project. It's called the insert anomaly. So, insert anomaly, delete anomaly, and update anomaly. Why? Why you got this problem? Because your database design is not good, which means your database design has redundant information. So you need to avoid, you need to remove such a redundant information. That is the second guideline. Third guideline, do you remember what is the third guideline? As less null as possible. You cannot avoid the null-free database design. However, the null does, what's the meaning of null? Nothing, not existing. That doesn't mean it's the 0 byte in your system. You need to use something code, something space to represent the nothing, null. So it's a waste of your storage. Also, it's very hard to manage. For example, think about the SQL. How can you compare null? Can you use the equal? No. Instead, is null. You need to always use special operation. Is null, is not null. So as null, as less null as possible. So null, we cannot avoid. We cannot create the database design without null, but as less null as possible. Then the last guideline is the no spurious tuple. For example, let's say this is our database design. Employee underbar location, employee underbar project 1. I know this is not a good example for the database design. Suppose that, okay, this is my database design for the company. This one has the employee underbar location, has the e-name and P location. Employee underbar project 1 has the SSN P number, hours, P name, and P location. I'd like to join two tables, natural join. What is a natural join? Combine two tables with what? Common attribute. What is a common attribute? P location is the same. So we can join with the P location in this case. Then let's take a look at the result of the join. You can see the 1, 2, 3, 4, 5, 6, 7, 8, 9, P number 1. So we can combine the two Cartesian product, then check the P location is the same. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9 is blah blah Beller and John B. Smith. However, we can see the another 1, 2, 3, 4, 5, 6, 7, 8, 9 for the Joyce English. With one social security number, there are many people, many names. So is it okay or there is a problem? Definitely problem. Why? It's because of the redundancy. Actually, only 1, 2, 3, 4, 5, 6, 7, 8, 9 is whom? It's John B. Smith. Okay? It's only the John B. Smith, but Joyce English or any tuple that has the asterisk here is the unexpected the result from the join. Why? Because of redundancy. You can see the employee underbar location and the employee underbar project are together into the one table. For example, here for the one employee, it has one employee works for the many projects, and the one employee has many project location. It's a duplicate data. So it's a redundancy. Because of redundancy, when you join, it creates unexpected result. That's called the spurious tuple. So we need to avoid such a spurious tuple. How? Get rid of the redundancy. So redundancy is kind of the measure of the goodness of your database design. Whether you remove such a redundant information from your database design. Okay, so this is the informal guideline. So one more time. One table, one meaning. and no update, no delete, no update, delete, insert anomaly, and as less null as possible, and no superior tuple when you join. So if you follow this informal guideline, pretty much good database design. However, this is informal. Informal means it's easy to understand. Because of this one, many of the students, without taking the database, they can create a simple database, okay, without problem. But if you have the, for example, when I joined the first database project, my project manager invite me his office. Then his room is I think the less than my office is not very big. So, but his room is covered by the ER diagram, then printed, then they show everywhere. Then he says that it's 1995, so almost 21, 22 years ago. Then the number of tables is 2,000. So for banking, the database system. So that bank is the number of customer at that time is 6 million, 7 million. It's not that huge, but it's more than 2,000. So which means you cannot use such an informal guideline to measure the goodness of the database design. So to address another approach for the normalization is a formal way. Formal means mathematical model, but it's still same idea. So idea of to decide informal guideline. So like the one meaning, one table. Intuitively we understand. But formally, what does that mean, meaning? How can you decide one meaning in one table in computer or mathematics? Mathematics, they don't care which one is employee, which one is the e-name. Okay? Think about how we can represent. At the time, we are going to use what is this? Y equals f of x. It's a function. When did you learn the function first time? Third grade? Fourth grade? The middle school? Algebra? Anyway, it's the basic of the algebra. So what is a function, by the way? Anyone? Still you use in your program language a function or definition. What is a function? So when I learned the function first time, I still remember the teacher. It's elementary school, I think around the 4th grade or 5th grade. So it's like a black box. You don't have to worry about what's going on inside. There's always input and output. Okay? If 1, output is 2. 2, 4, and so on. Which means times 2. So function is y equal to x. And or f of x is the 2x. If there is input, there is output. X going to 2x. So x determine y. Okay? So this is the input, determine y. If you have the input, you can decide the output. X determine y. So we can borrow the same idea to the database design. So our goal is to define what is the meaning, to decide the meaning. So we can group, for example, employee and e-name. Employee number and the e-name are the same group, right? But also project number and project name are another group. Okay? How can we represent such a group of the attribute? So, in other words, for example, employee number determine e-name, right? What is this one? Mostly key. Okay? It's not always the primary key. We can have the candidate key. Not foreign key. Foreign key is different. Foreign key is between two tables. But in one table, key determine other non-key attribute. Okay? Or what else? Project number determine project name. However, employee number cannot determine P name, right? So we can find such a relationship. How many meaning? 2 meaning. It cannot be employee name to P name. Employee number always determine E name because they are in the same group of the data. One meaning, one table. Project number determine project name or any other information. Actually, there is another one in this. Okay? That's the number of hours. Number of hours is what? Employee number plus project number determine one for each employee. For each project, how many hours? Well, so actually there are 3 meaning here in this the example. How can we represent such a 3 meaning? Using this relationship. This is called functional dependency. It's called the functional dependency. In short, FD. Same as this one. This is this sign. It's called X. Determine Y. X is what? Set of attribute. A set of attribute determine set of another set of attribute. Employee number determine E name, project number determine this one, and so on. Okay, so this is called the functional dependency. So X determine Y. So this is the functional dependency. So problem is whether we can find such a functional dependency or not. So this is the convert informal way to the formal way. So whether we can find the functional dependency. Okay. Where is the yes. So what is a functional dependency? Functional dependency, we'd like to find a set of the attribute that determine another set of the attribute. So at this time, the left-hand side is called any attribute belongs to the X side is a prime attribute. And this one is non-prime attribute. So prime attribute determine non-prime attribute. However, what about we will see another example here. So the first example, employee underbar DPT. So it is the database design. Okay. So we have the employee underbar DPT. Okay. In this case, SSN determine what? E name, right? So SSN is the prime attribute, and SSN E name is non-prime attribute. So that makes sense. And then SSN also determine B date. That makes sense. And also SSN determine address, and also SSN determine D number. However, SSN cannot determine directly D name. Okay? D name is determined by the D number. The D manager SSN is determined by D number. So at that time, we can say SSN determine E name, B date, address, and D number. Okay? So at that time, the left-hand side, SSN is called the prime attribute. The others are the right-hand side attribute is called non-prime attribute. So we'd like to determine the prime attribute, non-prime attribute. Question. What about this? SSN plus E name determine the address. Is it functional dependency or not? It's also functional dependency. Okay? Why? Because SSN determine address, even though we add the non-prime attribute, it will determine address. It's not a problem. However, we don't need this one because it's already determined by SSN. So our goal is to find minimal functional dependency. Minimal functional dependency means if we can remove one of the attribute, if still the same, okay, then we don't need this. Do you understand what I'm saying? So, for example, SSN plus ename. What if take out this? SSN still determine address, okay? Which means SSN is the minimal. However, if we remove the SSN, ename determine address, what if same name of the student or the employee? It cannot determine the address. So this time we cannot remove SSN. SSN is the critical part. So it's a core part, it's called the minimal functional dependency. So what we are interested in is a minimal functional dependency. Mostly left hand side is what? Primary key plus candidate key. Any key attribute is the left hand side. And the right hand side, non-key attribute. Okay, so that is the functional dependency and plus prime attribute and also non-prime attribute. At that time, SSN plus ename is called the super key. It's a key plus super key. But we don't need the super key. We need minimal functional dependency. Only primary key and candidate key attribute will be considered. So in this case, go back to the example. Which one is the prime attribute? SSN. The others, non-prime attribute. And this one, which one is the prime attribute? SSN and P number. Okay. The others are non-prime attribute. Okay. So that is the functional dependency. However, there are a bunch of the mathematical notation and the processing to determine the functional dependency mathematically. So that is called the inference rule. You already know the inference rule. Like the reflexive, for example, y is a subset of x, which means x determine y, and augmentation. But pay attention to the third one, transitive. X determine y, and y determine z. That means x determine z. Everybody knows that transitive. For example, this one. SSN determine D number. D number determine D name, which means eventually SSN determine D name. Okay, this is a transitive. So there are inference rules of the such a functional dependency using this. I'm not going to explain the detail each of them. Using this one, we can decide. Our goal is to find minimal functional dependencies. Couple of years, maybe 5 to 6 years ago, I'd like to explain in the classroom functional dependency, mathematically how to find the minimal functional dependency. This is the algorithm, but I explained for I think 2 or 3 weeks. So most of the students would like to kill me. So I'm not going to explain, but intuitively this is not a very difficult concept. So I already explained that our goal is to find the minimal functional dependency. In other words, which one is a prime attribute, which one is non-prime attribute. Why? What are we doing right now? We try to find the meaning. How many meaning? How can we group by meaning? Using functional dependency. In other words, ideally, how many functional dependency we need for each table? 1. That is the ideal case. In case 2, might be the problem. So we need to do something. That's the idea of the functional dependency. That is the user. That functional dependency will be used for normalization. So this is actually the step. This is the algorithm. Idea is, it's very well if you major in the mathematics. The concept is used a lot. Like whether we can find the minimal. Minimal is very important. So one of the main characteristics of the mathematics. So can you give me any word that describe the mathematics? Any word? Complicated? Crazy? Organized. Standardized. I like the one word. It's a simplification. Simple. Most of the math concept, not most, every concept is so simple. Think about something theorem. Pythagorean theorem, c squared is equal to a squared plus b squared. Right? So very simple. So obviously, the proof is sometimes complicated. Riemann theory or something, the Fermat, the conjecture, they are very simple. They try to, most of the math problem would try to represent complicated problem, very simple. It's a simplification. Okay? To simplify any problem, like the minimal. Minimal means simplification. So there are a lot of the way in mathematics to simplify. This is one of the techniques. How to simplify? So for example, this is just a general description. We try to find this is core part, minimal part. How can we determine we don't need this? Check. Take out this part, whether something different to one. If it's still same, we don't need it. This is additional information. And take out. Until if you take out the core part, something different, then we cannot remove this part here. So this is the idea of this proof, but I'm not going to explain detail. But idea is such a way. Then we can find the minimal functional dependency. Suppose that we have the minimal functional dependency from the database design. We are going to measure the goodness, decide whether this is good database design or not through the normalization. Before we start the normalization process, I'd like to remind you that I introduced the last time. We have the database design. Here. This is our schema. Schema is what? Do you remember? Anyone? Schema is description. It's a describe your database. This is kind of our boundary. Company schema means any table, index, foreign key, assertion, trigger, anything within this schema. That's the schema. So let's say this is the database design, but I didn't consider any normalization. I didn't consider any goodness measure. It's just put together in the box. Let's